Great. So thanks for having me, you guys. My name is Dr. Alexis Cowan. I did my PhD at Princeton. I graduated in 2021. After that, I started my business working with clients one-on-one and health optimization pursuits and performance optimization as well. I have a lot of professional athlete clients ranging from track and field, swimming, a lot of MMA fighters right now as well. So did that. I went back for my postdoc, which is what typically people will do if they go get their PhD and they want to be in academia. They'll go do the postdoctoral studies next. Did that for a year at UPenn, and then after finding some really great information I'm going to share with you today about quantum biology and light biology, I completely kind of changed my trajectory, and now that's like my primary focus is educating students within my business and also clients, and just getting the word out there on my podcast as well, which is called Undoctrinate Yourself, about the importance of these topics. So we're going to talk about light and how our devices and our bulbs like this were basically engineered to hijack our dopamine systems and make us dopamine slaves. So that's what we're going to get into. So to start, let's talk a little bit about chronobiology. I don't know if anybody's heard about circadian biology, but the circadian rhythm is the 24-hour cycle within the body that dictates a variety of things, including, during the daytime when we're getting the right inputs from our environment, it's stimulating digestion, cognition, learning and memory, muscle activity so that you can engage in performance pursuits as well, versus at nighttime where we're getting an absence of inputs, which we're going to talk about. That's the time for regeneration, repair, and tissue healing, wound healing, and recovery in general. So there are inputs called Zeitgebers or time givers in German that are these stimuli that initiate the circadian rhythm. And the number one input that has the biggest impact on the circadian biology is light. And so we're going to talk about that. So first, we'll talk a little bit about some specifics with regards to how this is happening. So in particular, there's one input into the body, which is blue light, which we typically in the ancestral environment would have received from the sun. So midday sun is about 25% blue light, about 50% red and infrared light. And then we have like less than 10% UV light and some other ones in there. But the blue light from the sun is really important with regards to the circadian clock because it's the signal that tells the retina to then communicate to the structure called the SCN within the hypothalamus within the brain, the suprachiasmatic nucleus. It's about 10,000 neurons, lives in the hypothalamus. 10,000 sounds like a lot, but it's actually very small. And depending on the blue light in the environment, it's basically determining what time of day it is. So if you're receiving blue light, your brain and then the rest of your body, by way of that master clock in the brain, is saying it's the middle of the day. So the reason that's like kind of problematic in our modern day is because all of our, again, device screens, LED and fluorescent bulbs are highly enriched in blue light. And if you actually learn about the history of why that is, it's pretty interesting because if you look at Google and Meta patents, they know that it hijacks the dopamine system, that it's highly addicting to be on screen technology and under this artificial light. And it actually kind of is rooted in the casino, like the world of casinos back in like the 40s. When casinos were first coming on the scene, they realized that if you block windows so no natural light can come in, and you have these slot machines with all of this like bright blue enriched light coming off of it, that people would sit there longer and spend more money. And the screen technology, I don't know if anybody's heard of MK Ultra, but this was like a government-sponsored CIA operation to understand mind control virtually back in starting in like the 50s and then going up through arguably today. And they found that this blue light could be a really good way to make people more impressionable. And it ended up in our screen technologies. And this is conspiracy fact, not conspiracy theory at this point. There's lots of information on this. So we can do a lot to mitigate our exposure. So for example, I'm wearing these blue blocking glasses right now. They're like 60% blue blocking. You want to get some blue light during the day because you need to actually have that blue light to tell your body it's the daytime, but you don't want to get too much, especially in isolation, because we didn't talk about this yet. But if anybody's heard of mitochondria, I'm wearing my Make Mitochondria Great Again shirt. And mitochondria are very sensitive to both blue light and red light, but in different ways. So red and infrared light actually stimulate the mitochondria to make more metabolic energy and water. Blue light has the opposite effect. So blue light in isolation, which we never encounter in nature, actually has inhibitory effects on mitochondria within the skin, the eyes, and the proximal brain regions. And so if you're not receiving that blue light with an abundance of this long wavelength red and infrared light, that's where we can start to run into some issues with regards to mitochondrial function. And of course, mitochondria are the most important organelles within cells to make all of the energy and metabolic water the tissues need to thrive, survive from a performance standpoint, but also from just a baseline health standpoint. If we look at all of the chronic disease burden we're facing societally, virtually all of it is rooted in mitochondrial dysfunction, from cancer to diabetes, obesity, autoimmune diseases, neurodegeneration, cardiovascular disease are all rooted in mitochondrial dysfunction in different tissues. And so let's see. Basic introduction to the electromagnetic spectrum. We kind of already got into it. We have both non-visible and visible light. The visible light is like our Roy G. Biv, and non-visible on each side of that. We have UV on the short wavelength side. We have infrared on the long wavelength side. We also have our non-native EMFs, let's say, which would be the 5G, 4G, 3G, Wi-Fi, Bluetooth, et cetera, are also on this spectrum on the long wavelength side of things, kind of in this area between radio and microwaves. So it's not visible, but again, that doesn't mean that it's not important, because we already discussed how UV, well, we're going to get to that, but UV and infrared are non-visible parts of the light spectrum that are very important for our physiology. And I would argue that UV and infrared are the most important wavelengths of light from a human bioenergetics standpoint. We're going to talk about that a little bit more. But with regards to the Wi-Fi and 5G, our mitochondria are really sensing the electromagnetic environment that we're exposed to. And so I think we just need a ton more research in this area. There's not a ton of high quality research. The researcher that was really hot and into this topic back in like the 1960s was Robert O. Becker. He wrote the book, The Body Electric, the book Cross Currents. And he went on 60 Minutes to blow the whistle about the negative impact of non-native EMFs on human biology. And he got canceled and lost his entire career essentially overnight. And there's another really good book called Going Somewhere, The Truth About a Life in Science by Dr. Andrew Marino, who was actually a student in Becker's lab, that ended up also becoming a lawyer to litigate the cases that were being held against Becker to basically try to silence him. So it's pretty shocking that this information isn't really being discussed. And again, I think the point of all of this is not to say we can't use tech, but we just need to be smarter about it and be honest about it so we can develop better tech. And I was talking to Lauren about, there's this company called Daylight Computer. They're making blue light free computers. They're in like tablet form now. They're going to be making phones. So this is just one example of how, we can just do better and make tech that's not going to harm us while also still reaping the benefits of it. Okay. So let's talk a little bit about some light biology interactions, starting with light intensity. So there's really two primary inputs that are important with regards to light and how it impacts our biology: light intensity and color temperature. So on the intensity side of things, this is to do with the brightness. And this brightness is also really important from a circadian standpoint, because when it comes to melatonin, which is our primary hormone released from the pineal gland in response to darkness, so when it gets dark out, ideally, we're not exposed to too much blue light or bright light, because that impairs melatonin release. That melatonin is what's required to go to sleep and stay asleep and get good quality sleep and recovery. So absolutely essential. Like when I'm working with my athletes, all of the circadian stuff, the light biology stuff has to be dialed in, because then we're going to get actually better workouts. We're going to get better recovery and, gain an edge on the competition, because barely anybody else is doing this stuff out there. And so that melatonin that's released is not only important for sleep, but it's also important from a mitochondrial perspective, because that melatonin goes into the bloodstream. It's bathing all of the tissues. Melatonin is also a really important antioxidant, helping to maintain a lower inflammatory environment, let's say. And also, we didn't talk about this yet, but infrared light from the sun or from firelight as well, which is enriched in infrared light, also stimulates the production of melatonin, but that melatonin is actually at the level of the mitochondria and it stays in there. So melatonin within mitochondria is really, really important for maintaining mitochondrial health. And that melatonin really requires infrared light as an input. And if you look at the light that is being systematically removed from our indoor environments, our modern environments, it is UV and infrared. We didn't talk about UV yet, but we will. So this is a problem, because in nature, even if you're sitting in the shade, green plants, if you're in like a natural space, reflect a ton of near infrared light, which is part of the shorter wavelength infrared part of the spectrum, that is really, really powerful for stimulating mitochondrial function and health. So even sitting outside is incredible for your health, independent of all the other factors that make it beneficial, compared to sitting indoors when we're behind glass that's all coated to prevent infrared light from coming in. And that's because infrared light is also known as heat, and heat is seen as essentially inefficiency within technology. If we want to keep our indoor spaces at set temperatures. We don't want the outdoor temperature impacting that. And so we're removing it from our indoor environments, not realizing that it's actually an essential nutrient for our bodies. I think that's one of the main takeaways that I want everybody to understand and just realize from our talk today is that there's certain light frequencies that are essential nutrients. I would argue each has their own role, and we're basically overdosing on blue light, and we're highly deficient in infrared and UV light. And that also applies to all of our light bulbs, the energy efficient bulbs. Incandescent bulbs were the ban on those started in 2013. The final ban is in 2028 because they're energy inefficient, because they have a whole bunch of infrared light. But the problem with energy efficiency and technology is creating an energetic crisis in the human body. And so hopefully I'm trying to be having some influence in this area to get this ban reversed on incandescent bulbs, because at the very least that can help to add some of that high quality light back into the indoor environment. Also worth noting here is that the grid didn't really roll out until the late 1800s, early 1900s. So none of these problems existed just like less than 200 years ago. And if we think about the evolutionary timescale, we cannot adapt that quickly to changing environments. It has to happen over millions of years, not a couple hundred years. So we're really suffering the consequences of our ignorance with regards to light in the form of chronic diseases and just, not feeling very good from an energetic standpoint. Okay, then we have color temperature, which you've kind of already alluded to. So color temperature has to do with the amount of red and blue in a light source. With our LEDs and fluorescent bulbs being highly enriched in blue and absent in the red and infrared, again, because they're energy efficient. If we think about natural light, sunrise and sunset are highly enriched in red light. That's why they look red. And midday sun is more enriched in UV and blue light. That's why it has like a whiter tone, doesn't look as warm in tone. And there's a light receptor that lives in not only the retina, but also in the skin, the fat, the subcutaneous fat, and the blood vessels, interestingly, called melanopsin. It's a blue light detector. And that's actually what is relaying the information about the light environment from the eye to the brain, that part of the brain that we talked about, that master clock, to tell it what time of day it is. And that melanopsin is highly, very exquisitely tuned to 480 nanometer light, which is like sky blue light, which should make sense because in the daytime, we're exposed to a lot of sky blue light just from the sky itself, but also from sunlight too. And again, this just really points to the importance of maintaining a healthy circadian rhythm from a recovery standpoint, from a learning and memory and cognition standpoint, and from a sleep quality standpoint too. We kind of already talked about melatonin, so I'll skip that. We didn't talk about cortisol. So cortisol, you may have heard of as like a stress hormone, but it's also a circadian biosensor in that it has a predictable rhythm in a healthy body that peaks in the morning and then gradually goes down throughout the day, and it has an inverse relationship to melatonin. So melatonin peaks in the middle of the night. We have cortisol peaking in the morning when you wake up, and it actually helps to get substrates liberated, like to get nutrients liberated into the bloodstream, to get the brain online, to get the tissues the energy that they need in order to be up and at it for the day. But cortisol also, outside of that, can also be stimulated by your light environment. So as it turns out, blue light in particular can stimulate the production of ACTH in the brain, which is the precursor that allows cortisol to be made in the adrenal glands. And so if we're under a lot of artificial light and on screens all day without any sort of filters that are preventing that input from interacting with our eyes, for example, then we can actually have elevated cortisol levels throughout the day, which can lead to muscle tissue catabolism. It can make it hard to put on healthy muscle tissue. It can impact strength gains. It can impact your performance broadly. It also can make you more injury prone. It can increase insulin resistance, so make you have higher levels of glucose at rest. And that's all physiologic, but it's because it's extended throughout the day versus just in the morning where we're supposed to get that peak or that spike. But there's so much we can do about that. For example, if we're going to be under artificial light during the day and on screens, you can wear 60% blue blockers. Nighttime, you really need to be wearing, starting around sundown, 100% blue blocking glasses if you're going to be on TVs or computers or under artificial lights like this, because that will eliminate that blue light that's telling your body that it's midday. We really need to get the signal of the absence of blue light into our system starting around sundown in order to optimize our sleep and mood and recovery and all of those things. You may have also heard about vitamin D. I would imagine all of you have, but vitamin D is actually really misunderstood in a lot of ways. Vitamin D is really a biomarker of your sun exposure habits. that's how it should be thought of, because if you look at the data on vitamin D supplementation, we can really clearly see that vitamin D supplements don't actually help prevent any of the disease states that vitamin D status is associated with. What I mean by that is, in the literature, we really clearly see that having vitamin D deficiency is associated with autoimmune diseases, different cancer types, neurodegeneration, and diabetes. But if you supplement with vitamin D, you don't actually improve any of those conditions. And that's because vitamin D is really just serving as this biomarker of your UV light exposure, in particular UVB light. So UVB light is the shortest wavelength of light we receive from the sun. It is the primary stimulus for vitamin D production in the skin from 7-dehydrocholesterol. That pre-vitamin D3 can then go to the liver and kidneys to undergo full conversion. If you get a vitamin D blood test, you're looking at the partially active form called 25-hydroxyvitamin D. That's really the biomarker form. The active form is called 1,25-dihydroxyvitamin D. That's the active form that is having a lot of biological roles in gene expression and muscle function, things like that. Not a biomarker. That's very highly regulated. The levels they don't correlate closely to the 25-hydroxyvitamin D at all. So if you're using a vitamin D supplement, the problem with that is not only are you not going to get the benefits you're likely looking for, but you're also going to be masking your ability to actually see your vitamin D levels from the sun. And so I highly recommend using an app called D-Minder. There's also another app called My Circadian that allows you to track a vitamin D session. So essentially, if you're going out and getting some sun, as much skin as possible exposed, you can start your timer, you put in your skin type and how overcast it is, and it will tell you how much vitamin D you're making per unit time. And then you can also plug in your starting vitamin D value, and it will help you to basically tell how long you have to stay out and how often in order to optimize your levels to ideally around 60 nanograms per milliliter or higher. Importantly, vitamin D is also already factoring in the amount of melanin in your skin. So the more melanin that's in the skin, the more sunlight you need in order to actually get that vitamin D up, and also the other benefits of UVB light, which we're going to talk about in the next slide. So ancestrally speaking, if we have darker skin, more melanin in the skin, that corresponds to a more equatorial environment that has high levels of UV light basically year round. And so that's like me. So I'm mixed, I'm half black, half white. And so I need more UV light than somebody who has lighter skin that lives in this latitude, which is 40 north latitude. If you look at the equator, obviously that's 0 degrees latitude, and that has really high quality sun. And you can also see that if you look at the top marathon runners in the world, they really are coming out of Kenya, like Nairobi, which is both at a high elevation. So they get way more UV light because of that. And it's at the equator. And that's why they have extremely dark skin, because they're dealing with a high UV light environment. But it's actually not just from a protection standpoint. So I really want to take a moment to talk about melanin, because it actually serves a really important role for harnessing free energy directly from the sun. So the way that that works is that UV light from the sun and full spectrum sunlight, when it stimulates melanin in the skin, it allows the melanin to split water molecules into 4 free electrons, which, if you remember from science class, the electron transport chain is what allows the mitochondria to make energy. So you can get free electrons simply from having your melanin stimulated by sunlight. You can also make molecular hydrogen and molecular oxygen. Of course, oxygen is the terminal electron acceptor in the mitochondria that allows that electron transport chain to occur. The molecular hydrogen is also involved in mitochondria. It helps to create that battery. So in the mitochondria, we have electrons being separated from protons. That creates a charge separation that literally creates a battery. And the protons are equally as important as the electrons in that context. Molecular hydrogen also plays an important antioxidant role, where it directly can quench free radicals, let's say. So from a melanin standpoint, we get free energy just by being out in the sun and cultivating the melanin in our skin, which is against what the centralized mainstream dermatologists will tell you. They'll say that there's no such thing as a healthy tan. It's just not true. When you look at the information on melanin, in addition to its ability to allow you to harness free energy, it also is a really potent heavy metal chelator. So it can pull heavy metals from your environment that got into your bloodstream out of the blood into that melanin and sequester it away. It's also a really potent antioxidant itself. So if you're in an inflamed state, that melanin can help to take up some of those free radicals to help prevent tissue damage. And there's also important implications with certain disease states as well. So Parkinson's disease is a disease of the loss of dopamine neurons in the brain within the substantia nigra. It's called the substantia nigra because it is literally dark, dark, dark in color because it's full of melanin. And that melanin actually is directly linked to the dopamine system. So both of them share the same precursor, tyrosine, which is an amino acid that basically you can break down melanin to L-dopa, and then that can be made into dopamine. So people who are having Parkinson's disease, it's highly associated with having insufficient sun exposure and low vitamin D status, which totally makes sense if you think about this melanin story as it relates to dopamine production. And that, of course, relates to movement quality. So that's why people with Parkinson's disease have tremors, for example, because the dopamine system is absolutely essential from a movement standpoint. This also relates to just performance optimization as well, because if you want to have good agility and good movement quality and be a good athlete, you also need to have a well-functioning, well-oiled dopamine system, because that dopamine, again, is extremely important from a movement standpoint. It's what allows muscle to react appropriately to a given stimulus or a given impetus that you're giving it to do a certain movement. It's also required for muscle fiber type switching, interestingly. So depending on what sport you're involved in, you may want to have more glycolytic fibers or more fat oxidative fibers. For like an endurance sport, you would want more mitochondria and oxidative fibers. For a more strength sport or an explosive sport, you want more of those glycolytic fibers, and this is also related to the dopamine system. So the other really important part of the UVB light story is this molecule called POMC, or pro-opiomelanocortin. So this is a complex prohormone that's cleaved into 10 distinct hormonal products. I have them listed here. I'm not going to go directly in this order, but 3 of the important ones you need to know are alpha, beta, and gamma endorphins. These are the endogenous opioid molecules, in the same way that, like, morphine or any of like the pain meds that are used in centralized medicine, they all work on the opioid pathways. POMC via these endorphins are also working on the same exact pathways. And when you understand that UV light is required really to synthesize these endorphins, most people think about like runner's high for endorphins. It's really a story about UV light. And it really makes a ton of sense when you see the opioid crisis we're facing societally, because we're constantly demonizing UV light. We're telling people to wear sunscreen every time they go outside, to wear sunglasses, contacts, prescription lenses when they're outside, so that UV light is being blocked from coming into the eye. We need UV light on both the eye and the skin simultaneously in order to reap the most benefits from sun exposure. And so if we're constantly deficient in our endorphins because we're not getting exposed to that UV light, now not only are we going to maybe experience more pain and depression and anxiety, but we're also going to be on this dopamine roller coaster, because another really important thing that the endorphins do is increase our baseline dopamine levels. And the major result of that is we have way less compulsivity. We're going to be less likely to reach for the junk food, reach for the social media, reach for drugs and alcohol, because we're already operating at a place where we feel good. We feel good at a baseline level. We don't feel like we're constantly in need of something to give us that hit. Compare that to like our blue light technologies. They have the exact opposite effect. They put us on the dopamine roller coaster to make us more addicted to not only that tech, but also more likely to reach for other things that give us a quick hit of dopamine, but then lead to a crash that makes us want more. So that's really, the story about endorphins. 3 of the other important cleavage products of POMC are alpha, beta, and gamma MSH, or melanocyte stimulating hormone. So as the name implies, melanocyte stimulating hormones stimulate melanocytes to make new melanin. And that's how you get a tan in response to the sun. So that's important. But in addition to that, alpha MSH also works on the hypothalamus within the brain to stimulate increase in energy expenditure and a decrease in appetite. So for anybody who, has friends or family that are trying to lose weight, or you had a weight loss period in the past, I'll personally say I lost 100 pounds when I was around your age. So I had a huge weight loss journey that could have been really expedited if I had known this information back then. But just getting enough UVB light will automatically suppress your appetite and increase your energy expenditure. That makes it easier to maintain a healthy body composition, or to achieve a healthy body composition in individuals who have higher BMIs. So extremely important from a metabolic health standpoint, from an appetite regulation standpoint. Again, UVB light is kind of anti-addictive in that it's going to basically make you not want the junk food, the hyperpalatable foods, the drugs, alcohol, etc., because you're already feeling like you're good. You don't need it. Yeah, just one thing I'll briefly mention here is that, again, this kind of ties in with what I just said a bit ago, that you really need to get the UV light exposure on both your eyes and your skin at the same time in order to reap the benefits. Essentially, what this is showing here is that if you only get the stimulation of POMC in this particular part of the pituitary gland, which actually comes from leptin and insulin signaling, then you're only going to make these cleavage products. One of them is ACTH, which of course can stimulate cortisol production in the adrenal glands, like I just mentioned. So we don't want to just create more cortisol. That's not really the point here. What we would love to do is create the whole repertoire of cleavage products via the hypothalamus and the skin. And we get that through UV light exposure in the eyes, which directly connects to the hypothalamus, and of course, direct exposure on the skin. We kind of talked about this already, so I just want to briefly mention again to compare to plants. So when we think about photosynthesis, we typically think about plants. Plants primarily leverage blue and red light to make energy and carbohydrates. So that's like 400 and 700 nanometer light. Human biology primarily relies on the infrared and the UV light to support our energy production and mitochondrial capacity. And so there's a paper I just included here called The Role of Human Photosynthesis in Predictive, Preventative, and Personalized Medicine. And so just suffice to say that melanin, instead of chlorophyll in plants, melanin in humans is actually what facilitates this process. Just highlighting here, sunlight is an essential nutrient. If you look at this table, there's a bunch of conditions here that are essentially protected against with regards to sun exposure habits. So we have all-cause mortality, asthma, cancer, cardiovascular disease, cognitive impairment, Crohn's disease, multiple sclerosis, Parkinson's, stroke, type 1 and type 2 diabetes. And somebody may ask, like, okay, wait, let me not go there yet. Somebody may ask, okay, so sunlight's great, but what about skin cancer? So I would love to highlight that because if you visit my Instagram, I also have a pinned carousel about literature in this area. The literature would actually tell you that if you have regular chronic sun exposure, so like if you get out in the sun every day for a period of time and you build a tan and you're not burning, that's actually highly protective against both melanoma incidence and severity compared to people who don't go outside or people who go out and they fry themselves. Like the worst thing you can do from a melanoma standpoint, which is the most lethal skin cancer, is to never go outside and then you go on vacation to the Caribbean and you get absolutely fried for a couple days. That's not healthy. That's actually not allowing you to harness the photonic energy of the sun either. We really need melanin there in order to harness that energy. And that means you have to build a base tan, so to speak. You have to build your solar callus, is what Jack Cruz would call it, who's a mentor of mine. And so from a skin cancer perspective, the own literature of the people who will say that no, there's no such thing as a healthy tan will contradict them in this, that if people are getting regular daily sun exposure, they're actually protected against melanoma. Not to mention that indoor workers are more likely to get melanoma than outdoor workers. So there's a lot of evidence against this. When it comes to the gut and digestion and microbiome health, it's something that I was focused on a lot before I found out on like the quantum biology light rabbit hole. And then I found out that light also modulates the microbiome. So it turns out that UVB light on your skin activates a skin-gut axis that increases microbiome diversity and helps with digestion, immune health, and if we actually think about it, so gut health and gut permeability increases that can happen in response to unhealthy environments, not getting enough sun, not being breastfed, being exposed to a lot of antibiotics. That increases your risk of inflammatory issues and autoimmune diseases. And UVB light actually has opposing effects on that. It helps to diversify the microbiome, which then in turn can help to tighten up the gut barrier, making you less susceptible to food allergies, IBS, IBD, things like that. This is just an image to show how the light spectrum differs across different light sources. So if we look at the LED bulbs, standard white LEDs, we have a huge peak in blue. In the fluorescent bulbs, we have a peak in blue, also a peak in green, and like a lesser peak in red. Incandescent bulbs, like I mentioned earlier, are really, really high in red and infrared. So that's like another reason why I think we really need to not be banning these things, because they're actually providing some of the light that we need in order to have a healthy metabolism. And then if we just compare all of that to the spectral distribution of sunlight, we see sunlight really has high levels of all these wavelengths from ultraviolet out to infrared. And so that's really what we need to be striving to recreate indoors if we want to have a healthy metabolism and create health and avoid disease. Just some literature showing that if you have lights on in your home at night, the bright white lights in the form of fluorescent or LED bulbs, that it impacts our sleep directly and it impacts our circadian system and leads to circadian disruption. And if you have light exposure at night, even low levels, less than 100 lux, which would be like a small night light or like a small lamp in your bedroom, or you're watching TV before bed, that is enough to create more insulin resistance the next morning. So if you expose people to very low levels of light in the sleeping environment, the next morning they have higher levels of fasting glucose, they have higher levels of fasting insulin, they are more insulin resistant, and they also have a lower heart rate variability, or HRV, which is a sign of how sympathetic to parasympathetic you are. We want that HRV to be high. That's a sign of nervous system flexibility. If our HRV is too low, that's a sign of sympathetic dominance typically, which means that you're stuck in like a fight or flight state, which means you're not digesting your food well, you're not going to be engaging in learning and memory, which requires neuroplasticity, meaning your neurons in your brain can form new connections or new neurons can be generated. And so some just basic takeaways for that: you can put electrical tape over indicator lights that you have on electronics in your room, or you can unplug them. You can use blackout curtains if you have any sort of street lights or any sort of light source outside of your windows. You can turn off all the lights in your room and your TVs and computers. And if you're going to be on screen starting around sundown, wear a pair of high quality blue blocking glasses to avoid the harms that these light sources can create in your sleep quality and overall health. So the big takeaways here are modern humans are highly deficient in red, infrared, and UV light, and we're overdosing on blue light. UV light dictates how well energy flows through mitochondria and also controls your appetite. And that free energy that's created in response to UV light is completely independent of mitochondria, and that you can harness free energy directly from sunlight striking the melanin in your skin. Even simply living an indoor lifestyle can make you blue light toxic and infrared and UV light deficient, and that's because standard window glass blocks infrared light. It blocks 100% of UVB light, and it blocks about 30% of UVA light, which we didn't talk about, but actually you guys might be interested in from an athletics perspective. So some people will take like nitric oxide boosters in order to get a better pump in the gym. But what these people don't know is that UVA light is the most potent stimulator of nitric oxide that we know of. The only caveat to that is you need as much skin exposed as possible in order to reap the maximum benefits of the nitric oxide boost, because that nitric oxide is produced locally in the skin. So just, working out in like minimal clothes, or, whatever you can manage to do in your workout setting, ideally outside, because you need that UVA light. That's going to help you get a better pump, because the UVA light stimulates nitric oxide, which then stimulates vasodilation, which helps to increase blood vessel dilation and the delivery of nutrients and oxygens to the tissues, as well as waste removal from tissues as well. So that's really important from an athletic standpoint. The more we can work out outside, the better off we're going to be, especially if we can also get our feet directly connected to the earth. Because as it turns out, there's special sweat glands on the palms and the bottoms of the feet that are called eccrine sweat glands. They allow you to create a direct electrical connection with the earth, and you can get free electrons from the earth that can directly support performance and athletic pursuits. So if you can work out, in minimal clothing, without sunscreen, without sunglasses, with your bare feet on the earth, and you do your lifting routines outside or doing sprints outside or whatever you're doing, you can get immense performance gains from that. And also you can do more work and you can recover better by doing that, because you're also getting that red and infrared light from the sun that can directly stimulate your mitochondria to make energy and metabolic water. So it's really like a perfect scenario for performance optimization to get yourself outside doing your workouts. And that's what I do. Like, I have a full Olympic lifting set at home. I just bring it out into the yard and I'll do my lifts out there. And the recovery is insane. Like, I literally haven't gotten sore once since making that shift. Let's see what I want to talk about here. What time does class end?
2:05.
Okay, cool. Okay, I'll go maybe a couple more things here, and then we can do some questions if anybody has them. Let me just see what I want to talk about. Yeah, so one thing I will talk about is mitochondrial DNA. I don't know if you guys learned in science class, but mitochondria share a lot of similarities with bacteria. There's this theory called the endosymbiont theory that basically states that bacteria turned into mitochondria over the evolutionary timescale. And so they both have a double membrane system. They both have circular DNA. And the DNA that's within mitochondria encodes the protein complexes that are involved in the electron transport chain, as seen here. So 13 of the proteins involved in this complex chain, are encoded by that mitochondrial DNA. So you can imagine that accumulating mutations within mitochondrial DNA would be harmful, because that means you're mutating the machinery that's required to make energy and metabolic water, which hydrates the tissue at a very fundamental level. So there's this concept called mitochondrial heteroplasmy, which says something about the mutation burden within a given set of mitochondria within cells. The important thing to note here is that mitochondrial heteroplasmy is really tightly associated with chronic disease and also aging. So an unhealthy aging process, you could be 40 years old and you could have mitochondria that look like you're 70 years old if you're living a very unhealthy lifestyle. Similarly, Dr. Doug Wallace, who's out of Children's Hospital of Philadelphia, is really the father of this work, but he's the one who discovered mitochondrial Eve and the fact that we inherit all of our mitochondria from our mothers. And so depending on the lifestyle of your grandmother and your mother, that will dictate the hand of mitochondria that you're dealt at birth. And it's also the reason behind childhood diseases, let's say. So things can be passed down mitochondrially from the maternal lineage that can then result in a disease manifesting in young kids. But the really important thing about mitochondrial biology and mitochondrial medicine is that it's very actionable. So there are two pathways by which we can remodel our mitochondrial colonies. There's mitophagy and there's mitochondrial biogenesis. So mitophagy, if you've heard of autophagy is when basically cellular debris, the garbage men come and like take it out and they can repurpose the materials into new structures. Mitophagy is similar in that mitochondria that have the highest rates of mutation will basically like put their hands up and say like, take me out. They'll be self-sacrificing. And then the mitophagy machinery can come in and break those down. And in effect, what you're doing is because you're depleting the bad mitochondria, you're in essence purifying the mitochondrial colony to increase the number of good ones. Then if you engage mitochondrial biogenesis, now you're amplifying the beneficial mitochondria, the good working mitochondria, and now you can actually create health from a disease state. The way to really do this is through a couple ways. So when it comes to mitophagy, it's really important to eat in a more circadian manner. So that what that means is you would have a bigger breakfast that could have more carbohydrates. Side note, you also want to eat a more seasonal diet from a mitochondrial perspective, which means in the summertime, you can eat more plant foods and lean proteins and seafood. In the wintertime is more of like a ketogenic or carnivore-ish type diet because those are the foods that are available when it's wintertime. If you're somewhere where the ground freezes and it gets cold, you can't get access to most plant foods during that time of year, maybe some ferments or some root vegetables, but that's about it. So if you eat in that kind of way, in a seasonal approach, that is also beneficial from a mitochondrial perspective. But when it comes to just the amount that you're eating, having a bigger meal in the morning and a smaller meal at dinner time allows you to get into a good fat burning state overnight and get into ketosis essentially. And then when you wake up in the morning, if you're up, let's say around sunrise or shortly thereafter, you combine that ketosis with a bunch of red and infrared light, and that supercharges mitophagy, which helps get the bad mitochondria out, in essence, purifying that mitochondrial colony. The mitobiogenesis, the increasing the number of good mitochondria, comes from exercise, also comes from UV light and basically moving your body outdoors during the day. So those are incredible strategies for helping to support your mitochondrial health. I don't know if I want to get into deuterium. Let's see if there's anything else I want to say here. Yeah, so maybe just some basic ways to improve your mitochondrial function, just as some takeaways. So we have watching the sunrise and sunset, as they're very enriched in red and infrared light that are supportive to mitochondrial function, as well as testosterone production in both men and women, and avoiding artificial light at night or mitigating our exposure to it, at least by maybe using red light bulbs in our house or wearing blue blocking glasses. Being barefoot outside as much as possible when you're like on the grass, let's say, to get that access to free energy. Getting enough midday sun to optimize your vitamin D status. We didn't talk about water, so just ignore that point underneath that. Engaging in cold thermogenesis, so cold water immersion and cold exposure is really, really great for our mitochondria. It helps our mitochondria to make their own light. So you can, if you get an infrared camera, you can see somebody on it because they're emitting heat. Heat is infrared light. So our mitochondria make a ton of infrared light. They also make UV biophotons, so they make their own UV light. That gets supercharged when you get cold. And that should make perfect sense because in the wintertime when it's cold, essentially what the body's doing is it's making its own infrared and UV light that's kind of absent from the natural environment because the days are shorter and the UV index is low. So getting cold is great for that. Also from a metabolic perspective, cold exposure is really wonderful for the mitochondria and glucose and fat clearance from the bloodstream. Seafood, eating seafood, and especially high quality wild caught seafood is really great from a DHA perspective, DHA being the long chain omega-3 fat. that's really important from an anti-inflammatory perspective, but also from brain health and eye health perspective. And then lastly, I just said avoiding fluoride. So there's a big movement right now to remove fluoride from public water supplies. And it was never evidence-based to begin with. If you actually look at the data there, now there's evidence showing that it's not only, innocuous, it's actually causing harm. And the towns that put the most fluoride in their water have kids with the lowest IQs. And so essentially what's happening there is fluoride is the most electronegative element on the periodic table. If you remember from like chemistry class, it's at the far upper right, ignoring the noble gases, but that means it's the most electronegative. Oxygen's right next to it. So we really want oxygen to be the most electronegative element in our bodies because that's what allows the electron transport chain to work. So if fluoride is in abundance within the system from water, from dental care products, etc., then we can begin to get something called electron steal syndrome, which basically means that oxygen is being deprived of electrons and it's slowing down our mitochondrial function. I think that's all I'll say for now. I think you guys have had enough. So if you have any questions, I'm happy to answer them. You can also learn way more about this on my Instagram. My handle is Dr. Alexis Jasmine, Jazmyn. I also have an ebook that I'm going to send to Lauren to give to you guys for free that outlines all the basics for this. I've literally had 6th graders and middle schoolers read this, and I had a middle schooler last month give a presentation to her class on my ebook, which was super cute. And so I'm happy to share that with you guys. Just even implementing basic things like getting bright sunlight in your eyes in the morning, in the middle, and also in the middle of the day. Just first thing when you get out of bed, instead of looking at your phone, try to get some natural light in your eyes. Doesn't mean stare at the sun, just get the natural ambient light into your eyes. Try to get some midday sun on as much skin as you can, and then start blocking blue light at night with a pair of blue blocking glasses. I like Bon Charge brand. There's also Raw Optics and Viva Rays. They're also pretty good brands. These are Bon Charge. Just doing your best to block blue light, especially starting around sundown, and your recovery will improve tremendously. Your sleep. I've worked with over 1,000 students and clients in the past 3 years, and I've had so many success stories just with very basic changes to the schedule. And so I think you guys could benefit tremendously from a learning perspective, from an athletic pursuits perspective as well. And yeah, that's all I'll say on that. So if anybody has any questions, I'm happy to take it.
Yeah. I'm curious, out of all of the clients you worked with, what was the #1 thing to change instantly?
Definitely blocking blue light at night, for sure. Because almost everybody's just on their tech all day and putting on bright lights at night. It's just the norm to, when it gets dark out, just throw all the lights on. So becoming more mindful around that, it just improves sleep quality immediately. I always used to be a night owl. I identified as that. And when I started making these changes within a day, I was literally waking up earlier and getting tired earlier, just naturally. I wasn't even trying. So the benefits and the effects are pretty immediate. And that's why it's also really good for buy-in, because you don't have to just intellectualize it. You can experience the benefits, and then that really gives you a motivation to continue implementing other things as well.
Yeah, if you can send along the brands of the blue.
Oh yeah, in the ebook I have everything in there, so it's all there. Yes, I'll share that with you guys.
Does anyone have any further questions?
Probably brain numb from all this information. Hopefully it wasn't boring.
Okay, well, thank you again for coming in. Everyone here, before you leave, we have a Canvas response. So if you can just take a look at it. I include Dr. Alexis, her website and bio and everything. So I want you guys to just kind of navigate that website, kind of like what we did yesterday, and give me a response of some facts that you learned from this discussion.
Thank you. Thank you for
guys.
having me.
Thank you.